Hello everyone, welcome back to my YouTube channel. So in this class, we'll be discussing about the logic gates. Fine. So what are logic gates? How the logic gates are working? What are different types of logic gates we have? What inputs output will be high? What inputs output will be low? All those things we'll be discussing in this video lecture. Fine. So there are few, few types of gates are available for your syllabus, out of which we'll be discussing about NOT gate, AND gate, OR gate, XOR gate, and two special gates, that is NAND and NOR. So NAND and NOR gates are called as universal gates, and NOT gate, AND gate, OR gate are called as the basic gates. So these three are the basic gate, these two are the special gates, or we also call them as universal gates. Fine. So let us see these gates one by one. Okay. First, let us consider the NOT gate. So NOT gate accepts one input value and produces one output value at any given time. Okay. So this is the symbol of a NOT gate, in which input is A, output is X. We have only one input over here. For one input, output will be 1. Okay. And this is the truth table over here. Truth table is having input and output. Okay. So as I'm saying that there is only one input, we can either give input as 0 or as 1. If we give 0 input to a NOT gate, output will be inverted version of this. So inverted version of 0 is 1. We give 1 as an input, output will be inverted version of 1, that is 0. We give 0, I repeat, if you give 0 as an input, output will be 1. If you give 1 as an input, output will be 0. So this is all. This is about NOT gate. And if you want to write a Boolean expression for NOT gate, it is written as output X is equal to A dash, or you can say A bar also, complement of A. So if A is 0, so A bar, that is 0 bar is 1, A is 1, 1 bar is 0, so output is 0. This is all about NOT gate, right? So let us proceed further. So let us see the definition of a NOT gate. If the input value of for a NOT gate is 0, the output value is 1, and if the input value is 1, then output is 0. Okay, and NOT gate is also called as inverter because it inverts 0 to 1 and 1 to 0. So let us go to next gate, that is AND gate. Okay, so AND gate always accepts two inputs. AND gate will be having two inputs. uh, Basically it will be two inputs. For some of the gate there will be more than two gates also, and for these two inputs, if both the inputs are 1, then only output will be 1. Okay, let us see that truth table. So two inputs we have. So input side I'm writing A, B, two inputs. Output is only 1. So X I'm writing. And since over here two inputs are there, so 2 to the power of n, over here is 2. So 2 to the power of 2 is 4. So 4 combination of inputs will be having. 4 combination means 0, 1, 2, 3. Okay, binary 0 is 0, 0, 0, 1 means 1, 1, 0 means 2, 1, 1 means 3. Okay, now you can see over here in the output over here. So first three outputs are 0, whereas only last output is 1. So if you observe the input conditions for this output 1, then input will be high, that is 1, 1. If A is 1, B is 1, then only output is 1. Okay. If both are 0, output will be 0. If any one of this is 0, then output is 0. If both are 1, then only output will be 1. Okay. And this is the symbol or logic diagram of one AND gate. And just see over here, this AND gate is similar to the multiplier. Fine. So you can see over here 0 into 0 is giving me 0, 0 into 1 is giving me 0, 1 into 0 is giving me 0 again, 1 into 1 is only giving me 1. The meaning is whatever truth table we have written, it is acting as though it is a multiplier. So that is X is equal to A into B. Fine. Next, let us take the OR gate. Now, this is the OR gate symbol, in which again will be minimum inputs required will be 2. A and B are the inputs. Output will be only 1, that is X. And let us see its output table. Again, two inputs means 4 possible input combinations, as we discussed before. So 0 plus 0 is giving me 0. 0 plus 1 is giving me the answer as 1. 1 plus 0 is giving me 1. 1 plus 1 is also 1 in this case. Fine. So from this what I can say is OR gate is working as a adder. Okay. A plus B. X, output X is equal to A plus B. A is the first input, B is the second input. So A plus B, whatever A and B value will be there, they'll be added together and it will be given as X. 0 plus 0 is 0. That is 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1 in this case. Right? So let us go to the next gate, that is XOR gate. This is the special gate. Okay. XOR means it is the short form of exclusive OR. Its actual name is exclusive OR. In short, we call it as XOR gate. Right? So an XOR gate produces 0 if two inputs are the same or otherwise 1. The meaning is if both the inputs are 0, 0, just see the truth table. If both the inputs are 0, 0, output is 0. If both the inputs are 1, 1, output is 0. So what is the meaning of this? How we can define XOR gate means if both the inputs are same, maybe 0, 0, then output is 0. Both the inputs are same means maybe 1 also in this case, output will be 0. So how we can define is XOR gate is a gate which produces 0 output when both the inputs are same. Fine. And for the other cases, we have one output. So we can define in other way also. If any one of the input is 1, output is 1. In this way also you can define. In this you say you take the second case. In the second case, A is 0, B is 1. So B is 1 means A is 0, B is 1. So one of the input is high, then output is high. Take this case, here A is 1 and B is 0. So in any one output is 1, output is 1, right? So this is what is called as XOR gate, and this is the symbol of a XOR gate. But to draw the OR gate, normal OR gate, in front of that if you write a one more curved line like this, then it will be your XOR gate symbol. And expression for this is given by X is equal to output is X is equal to A XOR B. Okay, so this is about XOR gate. Now let us go to the two special gates that are NAND gate and a NOR gate. These are called as universal gates. Why these are called universal gates means by making use of these two NAND and NOR gates, we can derive the functioning of any of the basic gates. That is why they are called as universal gates. Okay, so let us go into details of these universal gates. So first one is the NAND gate. You can see over here it is a AND gate. Just see this symbol. This is an AND gate. In front of a AND gate, I am putting one bubble. So this will make our NAND gate. Right? AND gate. In front of AND gate, if I put one bubble, that will be a NAND gate. So here also we require minimum of 2 inputs. So it will be only one, that is X. What this NAND gate will be doing is it will be doing the reverse operation of an AND gate. So in the AND gate, we have seen when both the inputs are 1, then only output was 1, right? For other combination, output was 0. So just see over here, when both the inputs are 1, then output is 0. For other case, it is 1. So whatever AND gate is there, the reverse of that is a NAND gate. I repeat, in the AND gate, when 1, 1 was the input, output was 1. Fine. For other cases, output was 0. Here in this NAND gate, when both the inputs are 1, then output is 0. For other case, it is 1. So it is the reverse of a AND gate. Fine. Now let us go to the NOR gate also. So what we are doing is we are taking one OR gate over here. In front of a OR gate, I am putting one bubble. This will be making my NOR gate. Fine. And this NOR gate is the inverted version of the OR gate. So in the OR gate, if you can remember, just go back and see that earlier part of the video. So for the OR gate, except for 0, 0 case, others were 1, 1. Fine. For 0, 0 output was 0. For other cases it was 1. Now in this case, for 0, 0 output is 1. For other case it is 0. Okay, this is all about our NOR gate. And remaining the expression. So our expression for NAND gate is output X is equal to A into B dash. I can say bar also can write. So an AND gate expression was x is equal to a into b, and here a into b dash. And for NOR gate, output expression x is equal to a plus b bar. In the OR gate, we had x is equal to a plus b. I said that it is acting as an adder, right? So here x is equal to a plus b bar, meaning is complement of the OR gate that we have. So whatever basic gate just now we discussed, they were having minimal inputs, right? So we can have the multiple input gates also. Just see over here, this is a symbol of AND gate. Basic minimum requirement for AND gate was 2 input. Now here we have 3 inputs. 3 input AND gate it is, and output is only 1. Fine. And you know that AND gate is acting like a multiplier. So when will the output will be 1? When all the inputs are 1. So 1 into 1 into 1 is giving me 1 answer. Fine. Okay. So this is all about basic and universal gates. If you have any doubts, comment me back. We can discuss it. Okay. Thank you.